Alright, so today we're going to go over function pointers real quick. It's a really basic example. So right here we have on line 4 a type definition for a function type. So basically what we've done is tell the compiler that we want to create a type for a function, or a prototype for a function that takes 2 integers and returns 1 integer. And then what we've done is when we went into main, we defined myAdd as a pointer to that type of function. So we created a function pointer this way. The other option that we have, which we did down here in line 5, is we defined a type of function pointer right off the bat, and that function pointer points to a function which takes 2 integers and returns 1 integer. So the difference here is that we didn't create a function pointer here. Instead, we created a function type, and then down here on line 18, we specified it as a pointer in this case. Whereas on line 5, we defined a function pointer right off the bat, and we type-defed it so that we can use it without having to type this whole thing out every single time. And so when we say math operation PTR, notice we don't actually have to write the asterisk here, or the indirection operator, because this is already a pointer. Whereas when we use regular math operation is not a pointer. It's a type of function, prototype, and we have to use a star to turn this into a pointer to that type of function. However, once we've gotten past that little hurdle there with that, then everything else is very similar down here. So when we're actually going to assign a function to these function pointers, then we just say equals add and then equals divide. My add equals add, my divide equals divide, and really all this is doing is it's taking the address of the first instruction of this function and it's placing it into this function pointer. Same with divide here. But unlike a regular pointer, function pointers also have to deal with arguments and parameters. So there's a little bit more going on behind the scenes, but that's the general gist of it. And the reason why that can be useful is because, let's say you're defining another function. Well, let's just say let's just say it's like this: do some math. So now we have int a, int b, and then we could say math operation star operation. Now what's cool is depending on whatever operation we want to do, this function can execute many different operations instead of just only add or only divide. So let's just type out something here. Let's see, so do some math will take whatever operation we give it, and it will do it will apply it to A and B. It'll say return that. So the whole idea here is that we're going to do some math, some numbers, and then we're going to tell do some math exactly which operation we're going to pass some pointer to some function in there. And what's neat about this is, we could keep adding new operations in the program and we don't have to change do some math at all, as long as those new operations that we define later on match this particular function prototype. So in this case, what it's going to do is it's going to call up whatever the operation is, and it's going to pass A and B to that operation. So the way you would call this is you would do some math In fact, I think I'm going to do a print real quick here. 10 plus, or 10 divided by 2 equals, let's see if this works, 10, 2. I might have messed up the way in which that's called up there, but I'm just going to give it a shot anyway. And I'm going to pass in here my divide. So this should print out 10 divided by 2. But again, I might have messed it up. We'll find out what the compiler says. Maybe not. There we go. So it worked. So what it did was it took, do some math, and since we passed my divide in there, it divided 10 by 2 because it took my divide, put it in here, and then it ran it with the 2 parameters that we passed to it. So basically the idea here is that I could then change this out for my add. And now that's all I really have to change. I mean, obviously it's going to say the wrong thing, but it'll still do the math operation. So it's going to do 10 plus 2. Well, it should do 10 plus 2, but sometimes when I don't know what it is, but when I build sometimes and then I run right away like that, it just freezes. And I have to actually just restart my command prompt, which can be kind of annoying. Like it's literally like it won't respond right now. And it's weird because I used to think it was because I was making a mistake with the program, but actually if I start up a new one like I just did right now and then I hit A, sometimes it'll run. But now it's hanging, so who knows what's going on. But anyway, we'll just look at the source code. So what it will do in this case is it will take my add, throw it into the operation, and then it will add the 2 numbers together, and then it will print it out. So that's the whole idea. And what's neat about this is what you can do, for example, is you could create a table of different functions that can be used by any given function pointer. So you could have like add, subtract, divide, multiply, and then you could ask the user, which of these operations do you want? And depending on whatever the user enters, it will look in the table and it will replace the function with whatever the user chose. So it's kind of neat. You could do stuff like that for like a calculator. And obviously function pointers can get a lot more complicated too. Let me open up another program for you real quick. Here we go. Check this out. So this is basically recreation of what a C++ class, or any real class really in an object-oriented language, the general idea of what it's doing in C. So basically what we have here is we have this struct called myClass, and it has just some data in it just for the sake of having it. So these would be fields if you're familiar with like C# or Java. I'm not sure if they're called fields in Java, but I know they're called fields in C#. So basically you have these variables that are attached to the class object, and then the class also has methods, which are functions that are part of the class object. And then what you would do is you can do something like you can be like like dog equals new dog, or whatever, like this, and then you could be like dog dot walk, and then this walk is a method in the class dog, basically, or in the object dog. So the way that actually works behind the scenes is this right here. If you'll notice, we have a very similar math operation type def like we did in the last file. And so this is a pointer to a math operation functions, and it's an array of them. Let me call it vtable. So this is an array of function pointers to math operations. And so we could place add, divide, multiply, subtract, and like 45 other functions in this array, or pointers to 45 other functions in this array. And essentially, those are methods on this class. And then, as you probably know, in like a different language, object-oriented language, every single method can modify the class variables or the class fields. And the way that's accomplished is each function takes one sort of hidden parameter, and that hidden parameter, in addition to the regular parameters that it needs, is simply a pointer back to the parent class, or a pointer, or the memory address of the parent class, and we call it this. And what that does, it allows each one of these functions to actually modify, like we're doing right here. It can actually modify one of these fields in the parent class. So then all you do is you just new up my class on the heap. So like I did that down here, you can see. So this is basically equivalent to saying, my class equals new my class or whatever. So this is my class. I put pointer. So my class pointer test equals malloc size of test. So all we're doing is we're allocating the proper amount of bytes on the heap for a new instance of my class. And then, as you can see here, we're taking and manually assigning the first 4 function pointers in the function pointer array to these different functions, prototypes, and definitions that we've supplied here. And then we can just go ahead and call them up, just like you would in a normal class. Test function pointer 1 or 0, basically, and then we actually pass these as parameters. So this is literally equivalent to us just calling the function add. So, and you can visualize this real quick right here. See how we did this? We can now go down here, and we could just, like, essentially, it's like doing this. Pretty cool. And then we didn't do it in every single function, but if you look up here, you can see here that we actually modified this number to whatever the answer is. And that will actually go up here and change the number in the parent class. Pretty cool. So let's see. I think this should still compile. In fact, I'm not going to build it, or I'm not going to save it, because I know I already have this thing compilable. So I'm going to do gcc classes.c g, and then I'll just write it for you real quick. Gosh, I don't know what's going on with my. I don't know if it's my command line, or if it's the compiler, or if I'm just rushing it, but I can't run programs right now. So, apologize for that. It's very strange, but it happens sometimes lately, and I'm not really sure why, so I'm going to have to do some investigation of that. It could just be that I am trying to do it too quickly. So, I'm going to try one more thing. Yep, I guess it's not going to work, because it's building fine. It's just my command line or something. It's not running programs. So, but anyways, I'll make another video and I'll do the actual demo of the program. But all it's going to do is just perform these different math operations down here, and then it's going to output them. And then on this one here, it will show you that the function actually modified the number field inside the class. So anyway, that's function pointers. Feel free to post any questions in the comments, and don't forget to subscribe. Thanks for watching. Bye.